Students, so I am starting a new topic today, which is required, which is present in your syllabus of BSc and MSc both, and that is solid state physics. The syllabus of BSc Part 3, generally it is taught in the BSc Part 3 course for the first time, although you have studied this thing in standard 12, and this is continued up to master's level. So in the solid state physics, the syllabus that is mostly taught in most of the universities is the crystalline and amorphous and glassy states, lattice translation vector, crystal parameters, primitive cell, Land-Miller indices, all those things. And thereafter comes the X-ray diffraction, the methods to study the solids or to investigate the structure of solids, that is the diffraction method. You have a lot of methods available today, X-ray diffraction, neutron diffraction, and many things are there. But since this is the first lecture of solid state physics, so I will start with the basic concepts first. This is the introductory lecture of your topic. So to start with the topic of solid state physics, we must have a brief idea of how solid is formed. Before that, I will start with a very primitive question, you can say, that what is matter or what is a solid state? Almost all of you, when you are students of graduation and post-graduation level, you know what is matter. It is something that occupies space and it has weight and mass, all these things. We are specifically talking about the solid state in this lecture. So matter, if we consider matter, means an assembly of particles. Assembly of particles. These particles, atoms, molecules, sometimes ions. So this is assembly of particles. Now this matter, if I ask you what are the states of matter, you will very readily answer this question. Being students of graduation and post-graduation, it is very easy for you to answer this question, and even the school going students can answer. They will say solid, liquid, gas, plasma, and sometimes people are saying Bose-Einstein condensate is also a state of matter, but that has not been experimentally verified to very accurate extent, so we can leave that solid, liquid, gas, plasma. But when you are in a graduation level or in a post-graduation level, you should know that matter is of two types. First one is the gaseous state, and second one is the condensed state. Because this solid state physics is also covered in the topic of condensed matter physics. And many times this question they ask in the interview, why it is called condensed matter. This condensed matter has two states, solid, liquid. Plasma is a different state. Plasma physics is different. If it is possible, we will study plasma physics also. So what is the speciality of this classification? On what basis the classification has been made? The classification of matter has been made in these two broad areas by the assembly of particles and the type of interaction that is occurring between the particles. The classification is done on the basis of the type of interaction between the particles. Type of interaction between the particles. In the gaseous state, when we are considering the gaseous state, it is something which is a state where the particles are free. You must have studied thermodynamics, and in thermodynamics we study the gaseous state. What are the properties? No fixed volume. These are the school level properties. No fixed volume, no fixed shape, almost zero interaction between the particles. They do not interact at all. No interaction between the particles. No interaction between the particles. There is no interaction. The particles are free particles, almost free particles, and they undergo collision among themselves and they create many physical phenomena. The pressure of the gas, temperature, they are studied in the kinetic theory. So this gaseous state, when we are studying the condensed matter or solid state physics, we are concerned with this third point, the interaction between the particles. Gaseous state is something which is present all over. The air around you is present all over. It does not have any shape. Now suppose you fill a balloon with air and the particles are inside this. This is the balloon. This becomes your system. These are the particles of air or any gas. So in gaseous state, gaseous state is a state where there is no interaction among the particles. This is one extreme end of matter. Is a state where there is no interaction among the particles. This is one extreme state of matter, that there is no interaction. Particles are totally free. That is why they do not have fixed volume and fixed shape. Now when these particles are starting to interact among themselves, they are coming gradually to the next extreme, that is the condensed state. Condensation, you know, condensation means when a gas liquefies and when a gas vapor is cooling down and it is taking the form of a liquid. So when the vapor is taking the form of a liquid, the interaction among the particles increases. As the interaction goes on increasing, it starts to take a definite shape and a definite volume. When the particles start interacting, or you can say alternatively, or when the particles have a force of attraction between them, they are getting attracted to each other, or there is a force that is causing the interaction, force of attraction between the particles. The gaseous state gradually condenses, and that is the condensed matter. Gradually condenses means the particles are coming close together, they are starting to have a force of interaction between themselves. And this condensed matter, this condensation, when it gradually condenses, it takes the form of liquid. When the force further increases, the force of attraction further increases, then it goes to solid. And there are many intermediate states in between, like the rubbery state, the glassy state, the amorphous and crystalline. All these states are basically condensed states of matter. So condensed state means a state where the particles have interaction among themselves. There is a force that is acting between them. Here we are mostly concerned about the solid state. Solid state, you mean fixed shape, This fixed shape is also not a very clear definition, because there are many solids though which do not have fixed shape. We will study them. The fixed shape refers to the situation that their shape is more fixed, more definite than the gaseous and the liquid state. Then the gaseous and liquid state, compared to the gas and liquid, the solids have more fixed shape. Or you can say geometry. This geometry is always not found, but compared to liquid and gas, they have a fixed geometry, fixed volume, denser than liquid and gases. These are the properties of solids that are observable, and they have electrical properties, thermal properties, dielectric properties, insulating, semiconductor. All these properties are on the atomic level. We are talking about these properties that are visible to us by naked eyes. That you take a piece of solid, it is fixed shape, it is fixed geometry, it has fixed volume, its density, it is harder than the liquid and gas. So first, when we have a piece of solid object, suppose this is a piece of solid object, what we have, what we see the external parameters. We see the external parameters. Later on we go to the atomic level and discuss the thermal, electrical, dielectric, semiconducting, insulating properties in detail. That is the part which will be covered later. But this is the thing that you observe first when you are looking at a solid. So these are the attributes of a solid state. Now this solid has different forms. The first one is the crystalline solid. Crystalline solid. Now what is a crystalline solid? This also you perhaps know. You will say that they have fixed geometry. Okay, it is very good. Fixed geometry. They are found in fixed geometrical shapes: square, cube, hexagon, diamond shape, very famous diamond shape, fixed geometry. Now this definition, or you can say shape, this definition is also school level. Most important thing that they have, the most important property that is of concern in the graduation and post-graduation level is that they have sharp melting and boiling, sharp melting points, not boiling. We are not concerned about the boiling because it is something related to the liquid state. Sharp melting points or freezing points. Sharp melting point means they melt at a fixed temperature. There is no temperature range. They melt at fixed temperature. For example, if you have ice which is solid, it will melt at 0 degrees Celsius. It will not melt at 0 in a temperature range starting from 0 to 2 degree. It is a fixed temperature where ice liquefies or water solidifies. So this is the most important property. They do not have temperature ranges. Temperature range of melting or freezing. They will melt or freeze at a fixed temperature. This is the meaning of sharp melting point. Another most important property, when you are now at a stage to investigate the internal structure of the material, crystalline solids have long range ordering. Crystalline solids have long range ordering. Long range ordering, what does this mean? What order we are considering here, talking about? Ordering means the arrangement of atoms. A fixed arrangement of atoms, a fixed geometry of arrangement, it continues to long ranges. This means of several atomic distances. In crystalline solids, what we find that they have a fixed geometrical shape. This fixed geometrical shape is due to the long range ordering. This means the atoms are arranged in a fixed pattern up to several atomic distances. This is the meaning of long range ordering of crystalline solids. We are now talking about the introductory concepts of crystalline solids. So they have fixed geometry. There are several types of crystals. We will talk about this. The mostly discussed crystalline solid is diamond. You have read about diamond. It is the allotrope of carbon, and it is the most crystalline solid, mostly discussed crystalline solid. It has a definite geometrical pattern only because the atoms are arranged in a fixed pattern, in a fixed arrangement throughout the crystal, throughout the structure, and that is why it has a fixed geometrical state, fixed geometrical shape. This is diamond, and diamond gets all its properties like luster and shine and refractive index that are attributed to the arrangement of atoms. The second class of solids is the amorphous solid. And the best example is coal. Then we have rubber. These are amorphous solids. Although rubber and glass, I will talk in detail about them in the later lectures. They are not actually very strictly defined as solids, but we can consider coal as an amorphous solid. What are the properties? That they do not have fixed shape. They melt in a temperature range. There is a range of temperature. There is no sharp temperature of melting. Temperature range. They have short range ordering. Short range ordering means that the definite molecular arrangement, short range atomic ordering. Short range atomic ordering means the definite arrangement of atoms. It does not continue throughout the structure. It extends only to few atomic distances. Means it in up to few angstroms. The definite arrangement of atoms, continue only to few atomic distances. And the best example is coal. So this is the second class of solids. Then we have rubbers and glass. From the layman points of view, they appear as solid, but they are not actually strictly defined as solids. So our discussion will start with the classical method, that is the discussion of the crystalline state. So let us have a outlook of the crystalline properties or the crystalline state. Crystalline solids. So we are now in a position, we have learned the basic properties of crystalline solids. Now we will go to some more details. So in general, a solid, it is a crystal if the constituent particles are arranged in a definite manner in the 3 dimension or in a periodic manner. This periodicity is very important when you are studying crystalline solids and the structure of crystals. So there is a regularity that appears in the crystal. For example, I am giving you a picture of quartz. A quartz you have studied, it is also taught in optics, and it is a very famous solid. So this is a view of the quartz crystal. So basically what happens, a definite geometrical pattern, a definite geometrical pattern repeats itself in 3 dimensions. This repetition is also termed as periodicity. So the crystalline solid has a periodicity or regularity. This, what does this mean? A fixed pattern repeats itself in 3 dimensions. When a definite pattern is repeating itself in 3 dimensions, then you get a crystalline solid. This crystalline solid is known by another term, and that term is called reticular structure. It is very rarely found in books or very rarely taught. Crystalline solids have a reticular structure. Reticular means periodic or definite or repetitive structure. This is the definition of a crystalline solid. This is the most basic property, and the most significant term is the periodicity or the repetitive nature, regularity. You can also say crystalline solids have a regularity in structure. Now the details of these aspects we will study in the next lecture, because I have the intention to keep the lectures in short time, so that it is not boring to you, or it does not consume much of your time. So if you have any question, then please do comment in the comment section, and for the timing, watch, like and share and subscribe the videos. We will meet in the next lecture with the more details of the crystalline solid. Thank you.